So now that we're done with the Algebra 1 review, we're going to move on to quadratics. And the first section that we're going to look at with quadratics is transformations. Now, before we can move on to actually transforming a graph, we've got to look at what is the formula for a quadratic in general form. And this is going to be y equals a times the quantity x minus h squared plus k. Just like we had with absolute value, everything stays the same in what it means. So a is going to be stretch, compress, reflect. H is going to be your horizontal movement in the opposite direction of what it appears to be. And then K is going to be your vertical movement in the same direction as what it appears to be. Now, we'll do a quick review of what A does. So remember that if A is equal to 1, we get a normally shaped graph. The one that is showing here is the parent function of y equals x squared. If A is greater than 1, then the graph is going to stretch and it's going to become thinner. If A is less than 1, the graph is going to be flattened out and become fatter. And if A is negative, then we're going to get a reflection across the vertex. We also have our minimums and maximums. Remember that the minimum is going to be the lowest point of an open-facing or an upward-facing graph. So it opens up and the range is going to be above the vertex point. If we have a maximum, then we're going to have a downward facing graph and our range is going to be below the vertex. Now, what does everything mean in general form? The first thing that we need to do is identify the A value in any stretch, compress, or reflect, which we just went over. Then we identify the H and K values. The H value is going to be the opposite of what appears in the equation. The K value is going to be the same as what appears in the equation. Now, the opposite of the H value is the axis of symmetry. So when you go ahead and put that H value into your parentheses as an ordered pair, remember that that's your axis of symmetry, so it's the vertical line that runs through the vertex, and both sides mirror each other across that particular line. The axis of symmetry and the K value combined together create the vertex. If the graph opens up, there's a minimum. If the graph opens down, there's a maximum. And remember that K is always going to be the minimum or maximum value. The domain of any parabola that we do in here is going to always be all real numbers. And then a graph that opens up has a range of greater than or equal to K. A graph that opens down has a range of less than or equal to K. The next step is you're going to create a chart with 5 values for X, 2 greater than and 2 lesser than the axis of symmetry. Choose values that are an equal distance from the axis of symmetry if possible. That way we end up with a symmetrical graph. And then the last step is to go ahead and graph it. Now, before we move on to graphing, we're going to take a look at all of the information that you need to provide anytime that you're given a quadratic equation. So we're going to skip over to problem number 3 and then go back to problems 1 and 2. So graphing a function of the form y equals ax squared. So we're given for y equals 3 times the quantity x minus 4 squared minus 2. What are the vertex, axis of symmetry, maximum or minimum, domain, and range? So the first thing we've got to do is we've got to figure out what is in front of the parentheses. And so that means that the a value is 3. So we're going to identify the a value is 3. And then we're going to determine that since 3 is greater than 1, we have a stretch. Since the 3 is positive, that means that it opens up. We're not going to have a reflection. Now, the next thing we look for is the h value. And what's inside of the parentheses is -4. So we're going to go the opposite of that, and we're going to say that the h value is 4. Then the k value is going to be -2, which is the same as what you see in the equation. Our axis of symmetry is simply x equals the h value. So that means x equals 4. When we do our vertex, the vertex we already know from the equation. It's the h value followed by the k value. So we get 4, -2 as our vertex. And remember to always write your vertex as an ordered pair. The next thing we look at is the maximum or minimum value. So we look at the y value of our vertex, which is -2. We also see that since the graph opens up, this means that we're going to have a minimum. So we have a minimum at y equals -2. Then our domain, we're going to write as either all real numbers or as in interval notation as -infinity to infinity. It's always going to be this whenever we're doing parabolas with quadratics. The only time that this is going to change is if we have a plus or a minus a square root. And then we'll end up having a parabola that's been turned on its side, and then domain and range are going to flip the way that we do them. The range, all we're going to do is look at either the k value of the vertex or we look at the minimum or maximum value, and that's going to be on this one -2. And since it's a minimum, that means that it's going to be the first number that we put into our interval notation, which is -2. And since it's going upwards to infinity, we're then going to put infinity. Now we're going to backtrack a little bit and go back to problem number 1. And in problem number 1, we're going to be graphing a function of the form y equals ax squared. So the graph of the function is, or the function that we're going to graph is y equals 1/2 x squared. So the directions tell us to make a table of values and ask what are the domain and range. We're going to go through and we're going to give everything. So our equation is y equals 1/2 x squared, which means that our a value is 1/2. Since we've got a positive, that means that there's no reflection, but because 1/2 is less than 1, we do have a compression by a factor of 1/2. Then our h value, we have no h value because there's no parentheses, there's nothing being added or subtracted to the x. So that means that the h value is 0. Then you have nothing being added or subtracted to the x squared, which means that your k value is also 0. Since h is 0, the axis of symmetry is going to be x equals 0, which means that our vertex, the axis of symmetry which goes in for x, is 0, and the k value is also 0, so our vertex is 0, 0. Then we look at our maximum or minimum. Since this graph opens up, we have a minimum, and the k value is 0, so that means that the minimum is at y equals 0. Domain, as always, is going to be all real numbers, and then our range, since we have a minimum, we have our first value is 0, and since it opens upwards, it's going to be going to infinity. What we're going to do next is then choose two values for x on either side of the vertex. The easiest values in this case are going to be -4, -2, 2, and 4. The reason being, whatever comes out of that x squared is going to be multiplied by a half, so in order to make sure that we have integers, it's always easiest to use even numbers whenever you're going to be multiplying by a half. When we run each of the numbers that we've chosen for our x values through and calculated them, we'll see that when x equals -4, we get y equals 8. When x equals -2, we get y equals 2. When x equals 2, we get y equals 2. And when x equals 4, we get y equals 8. So you notice that we've got symmetry with the y values. And if we choose the correct x values, it's going to look like that. Once we've got all of those, we're going to create an xy chart. So as our XY chart comes up, you can see that we can start plotting our values. We can take each of our ordered pairs and put them on the coordinate plane. Once we've got all of those pairs placed on the coordinate plane, we can then draw a line that connects all of those points, and there is the parabola that represents the solution. In problem number 2a, we're going to graph a translation of f of x equals x squared. So we're asked, how is the graph of g of x equals x squared minus 5 different from the graph of f of x equals x squared? Now, f of x equals x squared is our parent function, so we're going to go through pretty quickly and just graph that out. The equation is f of x equals x squared. The a value is 1, which means that our stretch, compress, and reflect is none. We have an h value of 0 and a k value of 0, so our axis of symmetry is x equals 0, and our vertex is 0, 0. The maximum or minimum, we have a minimum at y equals 0. The domain, as always, is again all real numbers, and then our range this time is going to be 0 up to infinity. Now in our second equation, we've got g of x equals x squared minus 5. The a value is 1, which again means that we have no stretch, compress, or reflect. We don't have anything being added or subtracted from the x, so that means that the h value is 0. We do, however, have a 5 being subtracted from the x squared. That means that our k value is negative 5. The axis of symmetry, remember again, is x equals h, so that means x equals 0. The vertex is h and k, so 0 and negative 5. The maximum or minimum, we have a minimum at y equals negative 5, and then we have a domain of negative infinity to infinity, again, which is all real numbers. And finally, a range, since the minimum is at negative 5 and it opens upwards, it's going to be negative 5 to infinity. The parent function is always going to use the following points. It's always going to be negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. Every single time, it's not going to change for the parent function. Now, for the second equation, we do have to figure out some points so that we can fill in our xy chart. So we're going to choose negative 2, negative 1, 1, and 2. We do this again because our h value is 0 and our a value is 1. So we don't need to make any adjustments to which x values we choose. So when we plug negative 2 in for x, we get y equals negative 1. When we plug in negative 1, we get y equals negative 4. For x equals 1, we get y equals negative 4. And for x equals 2, we get y equals negative 1. We then go ahead and create our xy chart. So here you can see we've got our two xy charts. We're going to plot the points. And once we've drawn in our line, we can see that the translation of the graph is 5 units down. So we're again going to graph a translation of x squared, but this time we're going to do it with an h value rather than a k value. So we're given, how is the graph of g of x equals x minus 4 squared different from the graph of f of x equals x squared? We've already got all of our information for the parent function, so we're going to go ahead and just fill that in. And then we're going to concentrate on g of x equals the quantity x minus 4 squared. The a value is 1, so again we have no stretch compression or reflection. The h value is going to be the opposite of negative 4, so we get 4. The k value is going to be 0. The axis of symmetry is x equals 4. The vertex is 4, 0. The maximum or minimum, again, we have a minimum because it opens up, and we're going to have y equals 0. And then the domain is all real numbers, and the range is going to be 0, and since it's opening up, going to infinity. We already know our values for the parent function, so we're going to substitute some x values into the second equation to find out what our y values are. Now, since we know that the axis of symmetry is at x equals 4, we want to choose 2, 3, 5, and 6 to plug into the equation. This is going to give us, or should give us, a symmetrical list of y values. So when we plug in 2, we get y equals 4. Plug in 3, we get y equals 1. 5, and we get y equals 1, and then 6, and we get y equals 4. So we do get that symmetry that we're looking for. Finally, we're going to take those points, put them into a table of ordered pairs, graph those ordered pairs, connect them with a line, and there is your translation for x minus 4 squared. In problem number 4, we're going to use vertex form and everything we've learned about a, h, and k to solve an equation and graph it. So we're given f of x equals negative 2 times the quantity x minus 1 squared plus 3. Our a value is negative 2. Since it's negative, we know that we have a reflection, and since it's 2, we have a stretch by a factor of 2. the h value. We have x minus 1, so that means that we've got an h value of 1, and then our k value on the outside is 3. So our axis of symmetry is going to be x equals 1, and our vertex is going to be 1, 3. Since this opens down, we're going to have a maximum at y equals 3. Our domain is again going to be all real numbers, and our range is going to go from negative infinity up to 3. We're again going to choose two values for x on either side of the vertex, and the easiest values in this case are going to be negative 1, 0, 2, and 3. And again, the reason why we choose those is because we've got an axis of symmetry at x equals 1, so we want two values on either side of x equals 1. When we plug those values in, negative 1 gives us negative 5, 0 gives us 1, 2 gives us 1, and 3 gives us negative 5. So now we have all of our ordered pairs that we need to go and create an XY chart. Once you've got that XY chart set up, go ahead and graph each of those points on the coordinate plane, connect them with a line. The parabola again shows you all of the solutions to that particular equation, and we are done.